Dear friends and colleagues, my name is Sергei Morozow and I'm very happy to be the speaker of the 42nd Polish Congress of Radiology, and I express my deepest gratitude to Andrzej Urbanik and Vadim Wojciechowski for welcoming me to the Congress. I'm very sorry for not being physically available, but thank you very much for inviting me, and I'm happy to give this presentation online. So I will speak about the imaging, and as you know, the 75% of the information that gets our brain, it gets through the visual images. And you see on this image the pictures that have been taken by one of the medical specialties. Guess which one? Just 1 second to think. And this is dermatology. So the standardization of imaging becomes widespread in all clinical specialties, not only in radiology. And here's the advertisement that I have seen in Chicago during RSNA. Here you see the text: if you use another MRI provider, have your head examined first. So it means that MRI is becoming a commodity around the world, and the competition mostly based on price, but not on the quality. So with rising amounts and volumes of imaging, the quality goes down in the majority of places. So you can see that the current healthcare transformation is characterized by accelerating digital transformation. Dermatology, ophthalmology, radiology, all of these are becoming digitized. The technologies are becoming very universal. We see commoditization, and art becomes craft with more standards. And the principle of Mayo Clinic expresses doing more with less resources. So the stress increases for the healthcare in general and for radiology in particular. For the challenges are the following. There's a goal and focus on process instead of result. We see the huge amounts of errors in diagnosis and treatment around the world, up to 25% of all imaging studies. The costs are increasing, there's a lack of standards, and healthcare and education are lagging behind other industries in the context of IT technologies. And the problems for healthcare providers are the following: cherry-picking principle. So I will only report the most interesting and most paid for examinations. There's shortage of qualified staff, high staff turnover, and slow implementation of new methods. And this is typical for many countries, including France, which provides this data, was providing this data back in 2009. So the quality is the problem. You see that also in Russia. According to our data, here you can find the example of patient with anatomy of kidney, which was described as kidney tumor, and that was the problem because the patient was thinking that he has a tumor. So this is false positive diagnosis, and of course there are a lot of examples of false negative diagnosis, of missed diagnosis. And you see in the USA the numbers from Institute of Medicine describe 100,000 deaths per year of medical errors. And you can manage only what you measure. The majority of countries do not measure the amount of errors in the diagnosis. We do it in Moscow by means of peer review system, and we have ratings of approximately 150 radiologists in the Unified Radiology Information System, for which we measure the quality of their reports compared to the images. And here you see the results of peer review of mammography. So the discrepancies in recommendations, 45%, classification discrepancies, almost 40%, incomplete reports or incorrect evaluation of the structures. So here are the examples of what is wrong in mass mammography examinations. So we have to teach people, we have to make audit, and then increase the level of qualification. So here you can see what are the sources of human error. And first of all, perception. Radiologists just do not see the pathology. You have to know what to find in order to make proper diagnosis. Problem of assumption. So we do not understand what we see, and problems of communication. We do not correctly communicate the results to the referring physicians or to the patients. And these are all typical sources of errors in radiology. In order to increase radiologist value, we have to focus on appropriateness, diagnostic accuracy, safety, provide actionable reporting and proper communication of results to the referring physicians. These are all important for radiologists. And the cycle PDCA is quite well known for radiology quality increase. And what we do is monitoring KPIs and run peer review project for approximately 5 to 10% of imaging studies, connected with the motivation of radiologists and connected with teaching program, which can become dedicated to specific needs of every radiologist. And here's the example of continuous improvement through digitization. We need modern management techniques, using balanced scorecards, using process approach, business analysis and standardization. We need telemedicine for balancing workload and communication with clinicians, with radiology information systems and hospital information systems. And we need AI-based systems to increase accuracy and efficiency of diagnostics for mammography, for CT. We run in Moscow low-dose lung cancer screening program, and we need tools, machine learning tools, in order to increase the accuracy of these programs. We also use NLP for analysis of texts. Here's the example of IBM Watson Explorer, which allows us to find the discrepancies between description and conclusion part of the radiologist reports in order to also search for possible discrepancies in the reports. Just in 2017, we've made almost 50,000 of peer reviews, and by combining peer review with teaching, we achieved a double-fold decrease in number of clinically significant discrepancies in the reports. This is very valuable for the patient management. And of course, radiology builds this defense role. And radiology now is acting in very difficult circumstances when we see more and more algorithms being developed for radiology. So the market for AI in healthcare is measured approximately at the level of $18 billion worldwide. And this is, of course, a huge threat to the specialty of radiology. The question is how to utilize these services and not being utilized by these services. The shortage of specialists is, of course, a problem for many countries. You know probably that report turnaround time in India is up to 3 months. 40% of studies in Japan are not even reported. And of course, more and more software companies, IT companies are building software services to analyze the reports and to help radiologists. Is it possible that radiologists will be substituted? Here you can see, here's the link, radiologists, approximately 20% of radiologist functions can be automated. For technicians, that percentage goes up to 50%. But that doesn't mean that we should not teach more radiologists. It means that we can increase the efficiency and we can make the work more valuable for radiologists, not just for collecting the previous images of the patients and aligning them for the future, for the next analysis. The question is how to properly assess the new algorithms. And here you can see FDA classification for software, and the current approach is to bring class 3 down to class 2, so to decrease the threshold for requirements for AI-based software and services for diagnostics. Viz AI provides very interesting approach for automated analysis of brain CT. And here you can see the list of companies which are currently FDA approved in the second class by FDA, and the applications are very different. So we'll see more and more of these companies coming to the market and offering their solutions. We have made analysis of several typical cases with existing online platforms which provide AI-based analysis of images, and we have found that currently they provide incorrect diagnosis or conclusions in 64%, in 82% of cases. So it means that the quality of algorithms should be rigorously assessed in the clinical trials. And here are the examples. Mediastinum, which is considered a lesion, lesion missed by AI, chin considered a lesion by algorithm. So these are errors for algorithms. You can check our AI runner project when we compare different companies with a standardized data set, and the CE mark approach is very similar to FDA in Europe. There is a data set published by a Russian team which is open for developers from different countries. Here you can see the registration, and our data set development roadmap consists of different use cases, and I think that we shall build more and more data sets for our partners who develop the algorithm. And of course, for current screening projects, that becomes more important because we get more and more information about the patients, and the possibility of human is limited in order to analyze that growing amount of information. The future is very nicely expressed by Eric Topol, who said that we need AI for document control, human error minimization, big data analysis and improved treatment, and for telemedicine and at-home patient treatment. Is the healthcare ready? Not always. Very often we are too busy to change something in our workflow. And I welcome you to see that new book on artificial intelligence in medical imaging, published by European Society of Medical Imaging Information. I'm proud to be ex-president of USOMI, Eric Ranchert. He is the current president of the European Society of Medical Imaging Informatics. So please check out our website, usomi.org. Download this book. It has thousands of downloads, really great team of experts. Here are the take-home points, and what we need now is the large-scale databases of annotated images available to the public to build the tools. So take a look at the take-home points, and I welcome you to see our online courses on basics of MRI, basics of CT. These are in Russian, but very popular by many specialists. Thank you for your attention and have a great Congress. My best regards from Moscow, from the European Society of Medical Imaging Information. Thank you.